All right, in Calculus 4.5, integration by substitution today. Most of it is not too difficult. There's one type of problem that's pretty tough, and I'll make sure I point which one that is. There's always one of them on the multiple choice part of the final exam and also on my test. So I'll make sure I make a point to you about how you could write it for your answer in the homework versus how the answer will appear for a multiple choice question. All right, so we're going to be looking for patterns today. Use substitution. For our integration. So the role of substitution in integration is comparable to the role was in chain rule and when we did differentiation. So it's the same idea today. I want to find this integral. Now I could literally FOIL this out and then distribute 2x, integrate each one, and actually have my answer. This one's not bad. Problem is if that was to the exponent of a 20, you are not going to want to raise that to the 20th power, then distribute, then integrate. So we need to find a better way to do that. So what we have is what's called this u substitution. You're looking for, if I was to pick something for my u, what would be my du? Your u is usually going to be the more complicated or the more complex polynomial. Or if we're talking about trig, like in this case, it would probably be the 5x because we can integrate a cosine of a plain variable, but not cosine of 5x or cosine of x plus 5, not cosine of anything else except a plain variable. So coming back up here for a second, my x squared plus 1 is probably going to be my u. That's the more complicated part. If I took this derivative, I want you to notice that would be 2x dx. See, right here, it happens to be my du. So I'm integrating u squared du. That'd be u to the third over 3. Plug back in for your u, and there's your answer. And you can always check these by taking the derivative of your final answer. It should go back to this. All right, if I let u equal the 5x, because again, I know the integral of cosine of a plain variable. I don't know the integral of cosine of anything else but a plain variable. So I let the u equal 5x. So the derivative of that is 5 dx. I have a 5 here. I have a dx there. That right there, those two together is the du, or are the du. I'm not sure which one's grammatically right. Cosine of u. Now, the derivative of what is the cosine of u? The derivative of the sine is the cosine of u. So this would be the sine of u. Plug back in for your u, and your answer is the sine of 5x plus c. So again, you're looking for what that u is. Think about what the derivative of it would be. Can you make the derivative happen? See, if I let u equal what's on the inside here, that would be x squared plus 1. The derivative of it would be 2x dx. That means I need a 2 right here. So if I need a 2 there, I could make that a 2x, and if I make that a 2x, I could multiply by 1/2 times 2. See, when I do that, 1/2 times 2, I really did not change this problem. That is equivalent to the original because 1/2 of 2 is 1. Now, this 2x dx happens to be my du. That means I have this coefficient of 1/2 out front. That's now my u squared, and there's my du. So again, I want to make the du appear. So when I took that derivative, it was 2x dx. I needed this to be a 2x, so therefore to multiply by 2, I'd have to multiply by 1/2 out front. So there's my 1/2 integral u squared, and there's the du. Add 1 to your exponent, divide by it. We've got 1/6 of u to the third, so 1/6. There was the u I'm plugging back in to this problem, plus c. All right, so my u, I can integrate a square root of x, but I cannot integrate the square root of a binomial. So we're going to take this binomial right here, and we're going to let that be my u. So u is going to equal 2x minus 1. Its derivative would be 2 dx. I need to multiply this dx by 2. If I need to multiply it by 2, what would I have to multiply by out front to keep the problem the same, to not change it? See, if I multiply by 2, I have to multiply by 1/2 to actually keep it the same. So this is now 1/2, the integral of u to the half, and all of that out here at the end is the du. Add 1 to your exponent. Divide by that new exponent, or dividing fractions easy as pie, flip that to multiply. So I really should have done 2 over 3 here. The 2's would then cancel, and that's where I got the 1/3 from. Plug 2x minus 1 back in for the u, and your plus c at the end, and there's the answer. So this is the one that I was saying that was a little bit more complicated. This is the one on the multiple choice test. A lot of people miss this one. I mean, you guys are not going to miss it because you're going to practice it and you're going to have it down. So we still start with that u because we know we can integrate the square root of a plain letter. So that means 2x minus 1 has to be my u. The problem is this time is when I take my derivative of it, the derivative of u this time is 2dx. So I need that to be a 2. That means I got to multiply by a half out front. So no problem. There's the half. There's the du. This is the square root of u. I cannot integrate with all these different variables. So I've got an x still, and I have a u. So what you have to do is go back to the original problem up here at the top, and you need to solve that for x. Solving that for x, that would be u plus 1, and then a half of each of those. So that's what I've done. So x equals u plus 1 over 2. Plugging that in for the x, I already have a u to the half and the du. Now, y'all, this is a denominator of a 2. That's really being multiplied that binomial times a half. Let's factor that half out here with this one to a fourth. U to the half times u to the 1 be u to the 3 halves. U to the half times 1 would be u to the 1 half. All right, we integrate. We're going to add 1 to that, divide by the new exponent, add 1, divide by the new exponent. Going to simplify that. I don't like writing this 5 halves like that and the 3 halves, so we're going to fix that. Now, like I said, so in your homework system, and it will count this right, you literally can type all of that, but everywhere you see this u, go ahead and plug in your 2x minus 1 for each of those u's. And your homework's correct, but that's not the correct answer for the test on the multiple choice part. And I believe on the my open response part, I believe I tell you guys to write it in a factored form, except you'll still have a plus c at the end. So to do the factored form, you would need to get a common denominator first. Common denominator, 15. So that means this fraction times 3, this fraction times 5. So I need to do that first. Now that I've done that, I want to take out the greatest common factor. Out of 6 and 10, I can factor out a 2. U to the 5 halves, u to the 3 halves. Take the smallest exponent. That would be to the 3 halves. Factor that out. Can also factor out this 15. So again, I factored out the greatest common factor. So first step, least common denominator. Second step, greatest common factor. Now I am ready to reduce the 2 into 4. I am ready to take this answer of 2x minus 1 and plug it back in for each u. So there's the u to the 3 halves. That's 2x minus 1 to the 3 half. 3 times my u, which was 2x minus 1. Then there's the plus 5. There's the plus c. Again, 2 went into 4 twice. 2 times 15, that's where the 30th came from. Now inside this set, I need to distribute the 3 and combine like terms. And that finishes the answer. And that's what the multiple choice answer looks like. They've given one of these on the final every year. I always have one of these on my test. So you need to make sure you do understand how to get to that answer. So which one is the more complicated one? See, that's what you're looking for in terms of your u. If I let u equal 3x, that's great. But the problem is I don't know an integral of anything to be the sine squared of u and the cosine of u. So that doesn't help to let u equal 3x. So I need to let u equal whichever one of these looks a little more complicated. Or, you know, like in this case here, the derivative of the sine is equal to the cosine. So I would want to let u equal the sine of 3x. Its derivative would be the cosine of u, remember if that was a u, so the derivative of the sine of 3x is the cosine of 3x times the derivative of that 3x, which is our 3dx. I need a 3 here, so I have to have a third out front. Now, the cosine 3x and that 3dx is all my du. This is my u squared, and I have a third of the integral. All right, add 1 to the exponent, that's 3. Divide by it, it's another 3. This is now going to be 1/9 of my u to the third. That was the u. Sub it back in. And again, you could check your answer by taking the derivative of this, going back to that. And to take this derivative, you would have to do the chain rule. Because remember, this would be sine of 3x in parentheses raised to the third power. So make sure you do that chain rule appropriately to be able to check if it went back to this. So we need to integrate again. I've got 3x minus 1 to the 4th. Some of you are going, yeah, you know what? I'm going to go ahead and raise that to the 4th. I will tell you if you do that, your multiple choice answers are not going to match. Okay, it's going to be in a factored form. So if we would let the u equal the 3x minus 1, then the derivative of that 3x minus 1 happens to be 3. And there's the 3 already. There's the dx. See, there's the du. This is u to the 4th. So if you integrate that, you get u to the 5th over 5. So u to the 5th over 5 and a plus c. It's just doing a little bit of mix of some of the stuff we've already done today. Nothing new still. Which one is a higher degree? Which one's more complicated? that's the higher degree. If I take its derivative, it's 2x plus 1. Oh, so if that's u, this is the derivative of that. So that's u to the first. That's its derivative. So when I integrate, that would be u to the 2 over 2. So therefore, there's the u to the 2 over 2. They're just showing you how to do it without writing down all the steps. If you prefer to do it this way, that's great. But if it's an open response test, you might want to show a little more steps than this. So if I let the u equal what's under the radical, because we can't integrate a radical with a binomial yet. That comes in Cal 2. So you're going to let your u equal what's underneath this, x to the third minus 2. If I take its derivative, that would be 3x squared. Oh, there's the du. So I'm just integrating u to the 1/2. That becomes 3/2. Divide by 3/2, that means times by 2/3. So therefore, this is going to be 2/3 my u to the 3/2 plus c. Again, if I let u equal the 1 minus 2x squared, a little more complicated part on the inside. So that derivative would be negative 4x dx. Oh, look at that, negative 4x dx. So there's my u. This is u to the negative 2. When you add 1 to that, you get negative 1 and divide by the new exponent of negative 1. Can't leave that negative power. It's going to drop down. And there's your answer. Now, I don't like putting the negatives out here because sometimes, y'all, those run into your fraction bars. Go ahead and just not put it here, but put it in the numerator would be better. So if I need to integrate the cosine squared of sine of x dx, the one with the higher degree is probably your u while you're in calculus 1. So if I let u equal the cosine of x, the derivative of that would be negative sine of x. So notice how to put a negative in the front and a negative there. Now there's the du. That's u squared, and I can't forget this negative here. So when I integrate, that's going to be u to the third over 3 plus c and this negative sign. My u was the cosine of x. So there it is, the cosine to the third of x over 3. And don't leave off the negative. So my u is going to be x squared plus 1. The derivative of it is 2x dx. So that's a 2x. That means I need a half out front. Okay, so there's the half, there's the 2x dx, so that's the du, that's u to the third. Okay, now I prefer to go ahead and change my limits right here. You do not have to. In the homework write-ups, I went ahead and left these numbers alone, and I substitute everything back in terms of x. Typically, if I'm integrating, students just seem to not quite get that, and so that's why I wrote the homework up a different way. I'm going to try to see if you catch it, this method. So this was all in terms of x, and these numbers were in terms of the variable x. This is in terms of u, so I like to make these numbers in terms of u. Remember, right up here, we'd already said u equaled x squared plus 1. Well, if x was 1, 1 squared plus 1 would be 2. And if x was 0, 0 squared plus 1, that would make u 1. And the reason I like to do this is then when I integrate this, I don't have to substitute back in for x. I have everything in terms of u. In other words, these numbers are for u, these variables are for u. I integrate, now I plug in 2 minus when I plug in 1, and I have my answer. In the homework write-ups, what you're going to see happening is right here for the u, they're going to substitute x squared plus 1 back in for the u, and then plug in the 1 minus you plug in 0. So when you plug 1 into that, you're still going to get 2. When you plug 0 in it, you're still going to get 1. So whichever method you prefer, just remember, if you change these numbers, then you keep this in terms of u, you don't sub back in. If you do not change these numbers, then after you integrate, you have to plug back in here for the u. Okay, the x squared plus 1, you've got to plug that back in, because then the numbers 0 to 1 were for x. The numbers 0 to 1 were not for the letter u. So just make sure whichever method you do, just make sure you understand the difference. All right, so one more of those complicated ones. So if I let u equal the 2x minus 1, my derivative is 2 dx. So I need a 2 here, so I need a half out front. And hopefully you're noticing I'm still going to have an x there. So, again, that's the half. It's a coefficient. I have an extra variable here. I got to deal with that extra variable. That's my du, and that is the square root of u. So if I was to solve for x, x would equal u plus 1 over 2. So this is the x. That was square root of u, brought it up. 2 dx, that was the du, and there's the 1/2. Now notice I went ahead and changed my numbers already. See, this was for x. 5, 2 times 5 minus 1, that's 9, which is now for the u. And 1, 2 times 1 minus 1, that's 1. So when I integrate this, I do not have to plug back in for this x right here. I do not have to plug in 2x minus 1 for the u. So at this point, I know this is I take this half out here. So this would be a fourth. U to the negative 1/2 times u to the 1 would be u to the 1/2. U to the negative half times 1 is that. Add 1 to each exponent, divide by your new exponents. Now remember, this is all in terms of u. The 1 and the 9 is for the letters u. If you don't change these numbers and you keep them 1 and 5, then the 1 and the 5 are for an x. You can't plug 1 and 5 in for u. Okay, that's why I changed my numbers. So now I can just plug 9 in for u and the 1 in for the u. So this says the square root and then to the third power. So plugging in 9, that would be the square root of 9, which is 3, to the third is 27. That's just the square root of 9. Then when you plug in 1, square root of 1 is 1 to the third, square root of 1 is 1. And then you simplify this all out and you get an answer of 16/3. So even with a change of variables, integration can be difficult, but occasionally we can simplify it over integrals because if they're symmetric with a y-axis or origin, if we know a function's even or odd, it'll help us. So if a function was even, do I really have to integrate from negative a to a? No, see, if it's even, it means it's symmetric with the y-axis. So I really could integrate from 0 to a and then take that answer times 2. But if a function is odd, meaning symmetric with the origin, if you were to turn it completely 180 degrees, the graph is exactly the same. So when it's symmetric with the origin and it's odd, if I integrate from negative a to a, this is a positive, let's just say that's positive 1/2. Well, then this would be negative 1/2, and when you add them together, it would be 0. So anytime you integrate an odd function from negative a to a, it will always equal 0. But an even function from negative a to a, it would equal 2 times the integral from 0 to the a value. So this function here, I need to integrate from pi-half to negative pi-half. So that's the function f of x. If I substitute negative x for all the x's. All right, guys. So if I went positive x degrees versus negative x degrees. So that would be like going from quadrant 1 to quadrant 4, for example. All right. So if I go positive x degrees versus negative x degrees, the sign here is positive, but the sign there would be negative. So that means that would be equivalent to the negative sine to the third of x. But let's look at the cosine. The cosine in quadrant 1 and the cosine in quadrant 4 are equal. So the cosine of negative x equals the cosine of positive x. So again, that became a negative value because it's in quadrant 4. Think of it that way, if x was in quadrant 1. Again, that right there would become negative as well, but that one becomes positive. This is the exact opposite of the original equation. So if it's the opposite of the original equation, then the function is odd, which means it's symmetric with the origin. And if you are integrating from negative a to positive a on a graph that's symmetric with the origin, meaning odd, then your answer is automatically 0. And that's what the graph of it looks like. All right, that ends our lesson 4.5, and that wraps up chapter 4 for you. You guys have a great night. We'll see you tomorrow.